right, here we go. My husband changed the room around, so I feel very red from being bricks in front of me and this red and black wall. But anywho, so our first set of notes today is going to be average velocity and average acceleration. So we've done this essentially already. We have done average rate of change. And so we used the integral, and then remember we multiplied it by 1 over b minus a. So let's see if I can get this. Yes, perfect. So before, when we did the average integral, we had 1 over b minus a from a to b of whatever function with respect to x, right? So we took the integral, so that was your f of b, oops, parentheses, minus f of a all over b minus a because of this, right? So we're going to be using that today, all right? But this time, since we've been doing calculus in motion, we're going to look at it as, so here's what we do for the average. This is what's different, right? When we say average, we do the 1 over b minus a. But this time we're going to be doing it with velocity and acceleration, okay? So EQ, how do I find average velocity and average acceleration? All right, so if we had the antiderivative from 1 over 5 of a of t, right, a of t being acceleration, I would take the antiderivative of acceleration, right, which is velocity, all right? So this is what I think you kind of missed from last week's notes because I didn't have this little webcam, but I always start with position, and then the derivative is velocity, and then its derivative is acceleration. And then if I'm going the other way, it's acceleration, its antiderivative is velocity, and then velocity's antiderivative is position. So if you always go position, velocity, acceleration, you can kind of remember the order. So derivatives and then antiderivatives. Okay, so the antiderivative of acceleration is velocity. So that's the same thing as that capital F, right? Because it's antiderivative. So the antiderivative of a is v, and then I would take v of 5 minus v of 1. Okay, similarly, I could flip-flop it, right? So if I gave you that, then I would know, oh, that's the antiderivative of acceleration. Okay, so just pause as you need if you want, okay? If you want to write stuff down. Okay, so here, if I have v of 3 minus v of 0, if we're using the one prior, right, if I get v, I'm not going to write it because it's going to pop up. If I get v, then that means I started with a, right? So if I get velocity, that means I was looking at the antiderivative of acceleration. This 3 and this 0 tells me my a and my b. Okay, so same thing here. Now I have position. So if I got position, that means I started with velocity, right? So from 3 to 8 of v of t. Okay, so just try to wrap your brain around that. Think about the order, position to acceleration. That's not the order. Position to velocity to acceleration. So if you're having the antiderivative of acceleration, you're going to get velocity. If you have the antiderivative of velocity, you're going to get position. Okay? Okay, so onto those averages, right? Average. Now, notice both of these are velocity. Okay? So it goes either way. Average velocity from a to b, I can take the antiderivative from a to b of v of t with respect to t and have that over b minus a. Remember, that is the same as that 1 over b minus a on the outside. Yeah? Multiplying by a fraction is the same thing as dividing by that. Okay? And then here, we just talked about that the antiderivative from a to b of v of t is the same as position of b minus position of a. And then again, we would take, so that's the top part is equivalent. So this v of t is equivalent to s of b minus s of a. Okay, and then notice both of them over b minus a. Okay, so similarly, we have average acceleration. Again, both of these are acceleration. Okay, we can choose to write it as the integral from a to b of a of t, because it's acceleration, over b minus a. That's the average part. Okay, or I can say, oh, well, the antiderivative of acceleration is velocity. So v of b minus v of a over b minus a, because again, that's that average part. Okay, and remember, this is slope, right? Crazy. Right? I have a y2 minus y1 over x2 minus x1. Spiffy, huh? So what's going to happen is I'm going to do some example problems right now, and we're going to be deciding which one of these we would use based on what's given in the problem. Okay? So, oh, this is just some extra info for you. Average velocity and average acceleration can be negative, okay? But anytime you're looking at speed, your answer has to be positive, okay? So that's just a little bit of information for you. So depending on what you're looking for, average velocity and average acceleration, you can have negative numbers, okay? So remember, velocity takes into account the speed, and then also the direction, right? So positive velocity would mean you're going to the right, negative velocity meaning you're going to the left. And then acceleration takes on whether you are speeding up or slowing down. And so it's looking at the direction the wind is blowing and the direction the object is going. So when they're both going in the same direction, then acceleration would be positive because it's speeding up. If the wind is, here's the object, it's going this way, and the wind is blowing it, it's going to speed you up. Okay, so that would be a positive acceleration, versus if the object is going this way and then the wind is blowing this way, it slows you down because you're against that wind. Okay, and then speed has to be positive. It wouldn't make sense. You're never like, oh, I go negative 10 miles an hour in this residential. That doesn't make sense, right? Okay, here we go. I think I have 2 examples for you, and then so 1 and 2 will be examples, and then 3 and 4 are homework. Okay, so an object is moving along a line such that, how am I doing on time? Such that its position function, 2t, s of t is 2t cubed minus 21t squared plus 60t plus 3 when t is greater than 0. Find the average velocity from 1 to 5. So notice I'm looking for average velocity, but I'm given position. So that tells me that I'm going to use this little formula. I copied and pasted it from the previous slide, or 2 slides ago technically. Okay, so I'm just going to plug it in. So I would take 2 times, my b is 5 cubed, minus 21 times 5 squared plus 60 times 5 plus 3. So that's s of b minus s of a. So plugging in 1, because I'm going to need space, I'm just going to say 2 times... Oh, I'm not going to do the 2 times 1 cubed because that's just 2, right? So 2 minus 21 plus 60 plus 3. Phew, just had enough space. All over b minus a, so 5 minus 1. Okay, so I'd plug that into my calculator, the top part, and then divide it by 4, right? 5 minus 1 is 4. And I get -4 units per second. Oh, my phone is ringing. Sorry. And so I get that when I plug it into my calculator. Okay. So that's that one. So since I was given position, I wanted to use, since I was given position function, I wanted to use the formula I had with position in it. So on my next slide, I'm given velocity and I'm finding the average velocity. So I'm going to use the antiderivative of velocity. So I actually have to find the antiderivative of this first. And so that would be 1/4 t to the 4 minus 5t cubed over 3 plus 3t. And then that is from 2 to 7, right? So I would plug in that 7. So to get f of b minus f of a, right? The fundamental theorem of calculus. So 1/4 7 to the 4th minus 5 times 7 cubed over 3 plus 3 times 7. All of that minus 1/4 2 to the 4th minus 5/3 times 2 cubed plus 3 times 2. Okay. All over 7 minus 2. Okay. So it kind of ends up same process or different process just because I'm using the different thing, but I still use the antiderivative and plugged in b and a. And so I would plug all that into my calculator and I would get 10.583 units per second. Okay. Units per second happens because it's velocity. So velocity is a speed, but it counts direction. So that's why we get units per second. Okay. So that's it. Your practice problems are going to be numbers 3 and 4. Number 3. Okay, same idea. This time we're looking for average acceleration. Here I'm given velocity, so that's important. And then again, finding acceleration. And this time I'm given the position function. So this one might be a little bit more work. Okay. And then the answers are going to be posted for you. Okay. So check your work and see what we can do. All right. Bye, guys.